Question 9.2 gives us a graph and asks us to explain the shape of the curves at 50 degrees and 60 degrees. So we would go to our graph and we can see that at 30 degrees there is 100% protease activity. So at 30 degrees the enzyme is working at its optimum temperature, it's working at its maximum rate. However, at 50 degrees and 60 degrees we're finding a decline in this protease activity. So this suggests that in both cases, in both of the temperatures, then the enzyme has become denatured. This will happen at a faster rate at 60 degrees because at 60 degrees there's more kinetic energy due to there being a higher temperature. Therefore, the bonds holding together the R groups between the amino acids are more likely to break quicker. So in both cases, the enzymes are denaturing. When the enzyme becomes denatured, the active site is going to change shape. This is due to the hydrogen and the ionic bonds breaking, and then if the active site then changes shape, it is then no longer complementary to the substrate, therefore no enzyme substrate complexes can be formed. So the Marc scheme is looking for the first mark, a reference to both of those temperatures denaturing the enzyme. The denaturation will happen faster at 60 degrees because there is more kinetic energy due to the higher temperature. The hydrogen bonds and the ionic bonds will be broken, so there is a change in the shape of the active site, so therefore it is no longer complementary to the substrate, so fewer enzyme substrate complexes are going to form because the substrate is no longer going to fit.